Hello and welcome to the Maven meeting and podcast on the Rust Station station. If you're listening to us, this is going to be a live recording, meaning that there are a few guests beyond our guest speakers. There are a few guests who listen and can ask questions in the chat room. They can't speak because that's only the three of us. But those people who are present here, you're welcome to ask questions there. Welcome, Eli and Igal. So our guest this time is Shalom, the CEO of Eureka Labs, and Igal Tabachnik, right?
Tabachnik. That's exactly right.
Okay, senior developer. And we are going to talk about your company and Rust and how you use Rust. So I think the first thing that, I think I should just say myself that my name is Gabor Sabo, and I'm helping companies with Rust and Python. And then that's about me, that's enough. And now please introduce yourself. Let's start with Eli and then Igal, and please, let's see.
So thank you very much, Gabor, for inviting us to this podcast. And even though you gave me the credit for being the CEO and the CTO, we have another person as the CEO of the company. And my background is very technological. I spent most of my career in engineering roles. I did a lot of languages, not Rust, and started from things like C# and C++, and ended as a Python developer, mostly for data science purposes. And a lot of my career I did in analyzing code. I worked for companies who analyze code both for quality and for security. So code and coding languages are a very great passion of mine. And the way we get to Rust is very different from code analysis, and we'll get to it today, but it's a great passion of me and most of the people in the R&D.
Great. And I'll introduce myself. So also Thank you very much for inviting us to the podcast. So my name is Igal Tabachnik. I'm a software developer, and I've also had an interesting career spanning from beginning being a .NET developer, and Eli and I worked together many years ago in another company. And we reconnected recently, and we'll talk about that in a bit. So I spent sometimes also working in the area of code tools and developer tools. So building tools for developers, which requires a very specialized set of skills. But in the recent years, I've switched careers and worked primarily as a backend engineer in companies that primarily work on the JVM. So my background in the last, I want to say, 8 or 9 years was doing backend on Scala. The language. So my journey to Rust is also a bit different from maybe of other people who come from maybe C++ background to Rust. I come from more of a functional language, and we'll talk about that shortly. And recently, Eli and I met, and I joined Eureka. It didn't take a lot to convince me to join Eureka, primarily because I knew that we're going to be developing in Rust, and this is something I wanted to try. And the product itself is actually very interesting, and we'll talk about that in a bit.
Yeah, so as I understand, I actually also worked with Eli. I'm not with him, but in the same company a couple of years ago.
Yeah.
So we know each other from there. But I really would like to hear a little bit more about the company. I mean, we haven't so please what I know so far is it's a very young company. It's only exists a couple of months, right?
Yeah. So in fact, we started working on founding Eureka last year. We started with a very open goal, like to improve something in crypto or in blockchain as a technology in general. And we were looking for a lot of areas where there are challenges which are both interesting in the technological aspect of them, and most importantly, to convince the investors that it's worth coming to the company, to have something with real essence, something where there's enough money today to work in. The reason I'm mentioning it is that a lot of companies in the blockchain deal with a greater challenge where they have to aim for the market which will be there in a few years, and they have to speculate, and it's harder. And what we're working on is something which is active today. There is a lot of activity both in terms of traffic and in money, and this is where we are. So what Eureka is doing is we're building a new block builder for Ethereum networks. So one of the things I'm going to do is to give a little bit of explanations, and I'm more than willing to accept questions, Gabor, on anything around it.
Yeah, so I should play here the devil's advocate, I think, and say that I don't know anything about this and please explain. But it will be quite easy for me because I really don't know anything about blockchain. So please also consider, I mean, I'm quite sure that in the audience here and then later on in the podcast, there are going to be people who are experts in blockchain, but I'm also going to be a lot of people who don't know anything about it. So as we go, please also explain a little bit about it. Do I understand correctly that actually you started the company without having any specific product or service in mind? Just you want to say, okay, improve something in the area of blockchain?
That's the story we usually tell. It's not just like we knew that it's going to be around block building. We knew that it's going to be around one of the areas which suffer from over centralization. I'll elaborate on it in a second. But we weren't sure what exactly was going to be the product or what's going to be the length of the technology which we'll have to develop in order to achieve whatever it's going to be. Eventually, it got to be something a little bit ambitious, challenging to develop. And the reason for it is, I'll have to explain a little bit what block builder is and what block building is in blockchain.
Okay, please go ahead.
So blockchain, as it sounds, it's a chain of blocks. So at every moment in the blockchain, another block is added to the blockchain, and this is how the whole chain is being formed. So what does it mean to build a block or to add it to the chain? So in every moment in the blockchain, some people want to send their transactions to the Ethereum network. Sending a transaction means that someone wants to run a smart contract, which is a piece of code which can be verified before being executed and can be verified about the actual execution it had, and it can be verified. So it means that if we have a smart contract which, for example, promises that we can swap assets between us, then nobody can change this code. And once we run this code, everyone can verify that it ran exactly as the code shows. So that's something which sounds a little bit trivial or not very interesting. But when we look at a chain of transactions going into a single block, then they have a lot of side effects between them, because it's like a regular program. So when one transaction touches a variable in the Ethereum network, then every transaction which comes after that will see exactly this side effect. So it means that ordering the transactions is a challenge, and this is where it's becoming interesting. So when we're looking at the problem of block building, it's just a problem of choosing a set of transactions and ordering them in the way which leads to the best or most valuable block. So this is something which is going to be with too many details, so we'll skip it. But the nice thing, which is easy to explain, is that building a block is an NP-hard problem. It's both equivalent to the permutation optimization problem, and it's also an AppSec problem. So we have to deal with an NP-hard problem and in order to be able to build a block. So this is the main premise of what we have to do, and the reason we're mentioning this and not anything else is this is why we have to choose Rust eventually. So if we have to summarize this in the most oversimplified way, building a block is the challenge of ordering a set of transactions or a set of actions and trying to predict or getting to the most valuable order of those transactions. So if you have to look at it, you can look at it as a kind of a black box, and we give to the black box a set of transactions or a set of actions in a specific order, and we get a value. And if we change this order, we will get a different value. And what we're looking for is the most valuable ordering, which we can create in order to build a block.
But who builds the block? So what I understood that there is the Ethereum network, or I don't know, it's a virtual machine or what, the service that runs on many computers. Okay, I read a little bit about it in the last couple of days. And isn't that doing the ordering of these blocks?
So the network itself is in charge of verifying that the blocks that the block builder created are in fact valid and can be satisfied as regular blocks, which could be placed online and be checked by everyone else. So what we have is we have a few sets of very few block builders on Ethereum. These are the entities which come before the transactions get to the blockchain itself. So we are off-chain, we're before the things get to the blockchain. We get all those inputs. We try to create a list of transactions in a way which is forming a potential block. And in every 12 seconds in Ethereum, there is an auction, and every active block builder can propose their block to the network. There is some kind of mechanism of how the block is being chosen, which practically says the most valuable block is being taken. And then the network goes to the validators and attestators who verify that the block is actually valid, that it respects everything on the smart contracts, and that all the results that it shows are in fact valid for the execution the transactions had. So the block builder comes before the Ethereum network and before all the cool decentralized entities. It created proposal for the network, and then the network chooses one of the proposals and verifies them with the nodes, validators, and attestators.
Okay. So if I may, I will also like to add. So personally, I don't come from a background in blockchain, so I had to learn all this from scratch as well, kind of a few months ago. This was very new to me. And the way I understand it is very similar. It's very, very technical, but the idea is you have kind of like an internet, a blockchain that's designed for executing code in the blockchain space called smart contracts. Smart contracts can be money transfers between different people, or there could be pieces of actual code, like actual state that's being executed safely and cryptographically verifiable way. So the flow is that there are millions, or there are many hundreds of thousands of these transactions being created every second and being placed in the network. What the block builders do is they pick up those transactions from the ether, pun intended, from the network. We call them orders. And then the goal of this block builder, of what we do, is, like Eli said, is to try and create the best and the most valuable ordering of these transactions. So once this block containing all of these transactions is created, we send it to those entities called the proposers. We propose the block, and then they can decide whether or not to take this block. If they take this block, they can then publish it and execute all of these transactions. And if not, every 12 seconds, this is the way the network works. Every 12 seconds, everything repeats. So a new block is being created with new orders, etc., etc. So the idea is that we are the block builder, which is what we do at Eureka, is the entity that's responsible for actually turning many of those transactions that are floating out there, take them, order them in a way that they will have the best chance of being picked up and executed, and do it again and again and again. And so there are not too many entities out there that are called block builders. There are a couple of those. There are a couple of big names out there, and what we're trying to do is we're trying to become yet another block builder that's hopefully going to be powerful enough by doing some optimizations in a way that we create the blocks.
Okay, so basically this block builder will run or can run on your servers, if I understand. So it's nothing really to do with the rest of the computers that are running the blockchain. Mm-hmm. They have some communication, but it doesn't have to. And it can be either open source or proprietary, right?
Yeah, and that's kind of the point. The idea The whole kind of the biggest reason why we chose Rust, and I will just say it up front, is it's kind of was a decision that was made for us. So there are some big open source projects that propose give you building blocks to build your own block builder. So we essentially what we did, we forked that. We took some existing open source infrastructure and we forked it in a way that we're adding our own modifications. But this entire infrastructure was written in Rust. And so we kind of went with that. So the Rust kind of has a strong presence in the blockchain space for historical reasons, but it's also very, very suitable because in the end, it's a server that gets deployed to the cloud, like real actual machines that run in AWS or whatnot. And essentially, it's a network. It's a machine that listens to traffic on the web, on the Ethereum network, but it's essentially a service that runs out there.
So two questions come here. First of all, okay, so you forked it. Is your code or is it open source or is it closed source or how or what's going on with that?
So our builder is closed source. If we see bugs or improvements which are general to a general block builder, we submit it back to the original fork. But when we are developing new features, the new features are a little bit beyond block building, and take advantage of what people can do with it. And so these things are not being open source. So we leave them closed source.
Yeah.
Okay.
So the license for it it's either MIT or Apache. So we do submit a couple of fixes upstream. So basically that thing is being developed in the open, and we submit patches to it when we can. Those things that are going to be useful for the general audience. But we kind of extend the product, extend the platform in a way that's proprietary, and right now it's not open source.
Okay, and then so how do you earn money from this? Is it like if your block, if your chaining or whatever it's called, your result is accepted, then you earn some money? Do I understand correctly?
Yeah, this is exactly how it works. And when a block builder wins an auction, and this block builder gets a fee.
Okay.
It's varying between every block, but depending on how valuable you made it, then this is how much fee the block builder can take.
Okay, so you have to be fast and clever, and basically mostly these two things, right?
Exactly. That's primarily the reason why you would want to pick a language like Rust to do this, because you want to be both. Well, there are three things that you want to be. You want to be first and foremost correct. You need to ensure, because we're dealing with things that depend on, well, they are order sensitive, they're hard, but they also have to be verifiable in the end. There's a lot of verification steps and a lot of cryptographic hashes that go on, and those calculations need to be both very, very fast in terms of their execution, and also we have to be verifiably correct, which means that when the block that we create is going out to the network, we have to be able to ensure that it contains exactly what we said that it will contain. And this is where Rust's, for example, type system makes certain guarantees that ensures that the block will be created correctly and verifiably. So we have a bunch of tests around it, but also the type system ensures that the structs contain just the data that is expected.
Okay.
And of course, the performance because of it, because Rust is it's a systems programming language in the end. So everything runs natively on the machine. There's no JIT, there's no memory management, there's no garbage collection. So everything kind of runs very, very fast and in a way that's expected of something that sits in the network and deals with high traffic, deals with the high traffic essentially.
Was there any consideration was there any consideration of using any other language, or it was so much given that it has to be Rust that you didn't even think about other language?
So we did start with experimenting with other languages. So if surprisingly, we started with Python, and we thought that we could just do all the heavy lifting on mathematical operations with NumPy and stuff like that. But it was far from the reality. And the reality, there needs to be a lot of real execution of code on EVM, and Python will never get to the right performance. So this was an approach we had to ditch quite fast. And the other competitor is Go. So a lot of projects are based in Go, and also one of the largest block builders in Ethereum also implemented in Go. And the reason we had to choose between these two is that there is a main entity called the node, which holds all the information in locally for the Ethereum network. So when building a block, there needs to be a lot of access to the storage of the network, and it has to be placed locally. And one of the things we realized that it's very efficient to write in the same language like the node we're working with, because they can share some code, they can share processes inside the same machine, and then they can share memory. So basically the reason to choose Rust was because the main node we're using is implemented in Rust. So this leads a lot of the choices of companies to work in blockchain, to work with Rust, because there's a main entity to work with. It can be communicated as a black box, like in HTTP, or it has extensions where people can run things inside the same process of the node itself. And if we run our builder as close as we can to the node, and if we write it in Rust and we can share the same memory, and then we can get the best performance.
Yeah, and also there are additional benefits. For example, the node itself, it's called Reth, R-E-T-H. So it's a Rust implementation of the Ethereum network. It's also open source, and it introduces a lot of libraries that we use internally that provide you with primitives for the system. Everything from describing sums of money. And yes, exactly, R-E-T-H, Reth.
Okay. I just wrote it in, people listening to us, I just wrote it in the chat because I wasn't sure the spelling, and so I'm going to put it on in the show notes.
In fact, I made a bunch of links of things that we're going to mention, and maybe we can put them in the end as like a show notes.
Yeah, definitely. That would be a very good idea. Thank you.
So, yeah, the idea is that a lot of libraries that can be reused, like with primitives, with abstractions, for example, the Ethereum network implements a lot of protocols, which are all published. They're all kind of described in white papers. It's all fascinating. Everything is kind of documented, and there are a bunch of different implementations, and the most popular ones are in Go and Rust. And so the Rust implementations they're very robust, and they're very, I would say, idiomatic to the Rust language. So everything works as you would expect a real Rust code to work. So for example, you have bounce checking, and you have smart macros. So for example, you have even things like addresses. If you want to send, like everything in Ethereum is like an address from and to. So you have to know who you're sending from and who you're sending to, whether it's money or anything else. And this is just a big hex number. And so in order for you not to spend any time parsing strings or just dealing with general validation of whether or not you were given a correct address, you just use a macro, for example. There's a macro in these building blocks called address bang, which in compile time validates that you are using correct address. So it alleviates a lot of headaches and a lot of kind of these small mistakes that you can get with languages that are not as robust probably for dealing with this. Like you can probably implement any of these things in any other language, even like obviously people do it in Go. But the added benefit of Rust, from my perspective, as somebody who uses daily, is that all of these little patterns that the language encourages you to do, like going through safe methods and implementing safe conversions, ensures that you're less likely to make a mistake, especially when you're building payloads and parsing payloads at runtime. You are more or less guaranteed that your execution will be flawless as long as you handle everything during compilation, during design time of your program. And this is, again, this is one of the primary reasons why in the end we chose Rust, is that there's this added guarantee of safety that the language is built upon. It provides you with a lot of functionality, so to speak, that ensures that many of these things the compiler will handle for you. And if you're making a mistake, the compiler will aid you and tell you what exactly you're doing wrong. And so you will have much fewer runtime surprises, which is, in my opinion, is the best possible thing that Rust can do.
Right. Back to a little bit for my understanding, you mentioned node, that there are these nodes. Isn't the Ethereum network is just these nodes? So when you say the Ethereum
Yeah.
When you say Ethereum, it's basically just the nodes, right?
Yes.
Okay. And so it's as much as I understand, that's an open source project basically, right? Written in Rust. So all these nodes are written in Rust.
So there are many implementations of the nodes.
Okay.
The most popular ones are in Go and Rust.
Okay, so the nodes, so also there are different implementation of nodes, not just the block builders.
Yeah, there can be infinite implementations for the nodes.
Okay, and then I guess there is some API or some definition that they must work this way.
Yeah, there's a spec basically on
right.
ethereum.org. You have the entire spec, all the white papers of many smart people wrote many years ago, and all of these things are just implementations. And yes, they have to agree on a common protocol, on a common language. Essentially, in the end, your payloads are encoded in. There's a special type of encoding. There's a special type of encoding of how the actual raw data looks on the wire, but every implementation, whether it's Go or Rust or anything else, really, I've seen people do it in JavaScript as well, of course, because everything can be done in JavaScript. They all are able to handle it and talk to each other.
So how do they manage upgrades? I mean, if one of these nodes, so if they want to introduce a new service or I don't know whatever new something into the network, then someone implements it in one type of the nodes, and then the others don't know about it. So or they are not implemented yet. So not only talking about not talking about rolling out to the same code base to maybe hundreds or thousands of nodes, which itself is a problem. But if each node might be in different might be a different code base, then how can they make progress? Or what happens if I mean, okay, so you add a new feature, then it can't work yet because the others don't understand it yet.
Yeah, so on the network, nobody can add a new feature on their own. And the idea for which there are many nodes is to get to a majority, and the right thing is always what the majority says. So if we have just one node which decides to deviate from the others, this node will be disregarded because it will always be the minority and nobody will take it seriously. Usually this node will get punished and the reputation will be harmed or slashed. I'm not exactly sure how they being incentivized not to do it, but a node can decide on its own to change the behavior
or stay behind.
Yeah, but
right. If all of them are moving ahead to something, then I also have to move because otherwise I'll be different, right?
Yeah, definitely. So the idea of the majority holds all the time. So once a big change needs to come to Ethereum, usually it comes from the Ethereum Foundation, and they promote it through something called EAP. It's an improvement proposal for Ethereum. It takes a very long time to get to an agreement, and once it's done, the spec of the nodes changes, and then the community decides on a date in which all the nodes have to change to the new version.
Yeah, so the idea, yes, this is the protocol governed by the Ethereum Foundation, and all the major upgrades to this to the way that the way the protocol works has to be documented, agreed upon, discussed potentially for many years until they finally pick up a code name, which is usually a weird name of some sort, or maybe like a city. There was, I think there was something called London, maybe. I don't remember exactly. And yeah, they decide to switch. And so yeah, so those things don't just nobody can really add a feature to the Ethereum network because it has to be. It's like I don't know. It's like would be adding a new feature to the internet. That would not make real like to TCP/IP. It would have to go probably through.
Yeah.
I have
There are
no.
standards. Yeah, those are
Yeah.
the standards. Yeah, so you have to go with the standard.
Yeah.
And, I mean, you can add a new service to the internet and you start doing between two computers. But if you want to change how the TCP/IP protocol works, well, that good
Yeah.
luck.
Yeah.
Or how even what HTTP is or whatever. Yeah, right.
Yeah. Yeah.
So. What else? I wanted to ask something else about this. Yeah. How many nodes are there? This is something that I was. How many nodes are there in the network? Like more or less, it's thousands or millions or.
No, it's a lot. There are 1 million registered nodes which perform validation. It's something which forces them to be up and to be like a very active node. So there are just 1 million nodes of validators, and there are many million of other nodes which are just out there, just collecting data, storing them locally like we do. So it's a few millions.
Okay. So
Yeah.
the point is, or when I started to learn a little bit about blockchain, and then I understood, okay, this the majority decides. That's the point that more or less where I reached in my understanding. And then I was wondering, okay, fine, majority decides, but if there is a wealthy person or a country that wants to overtake this whole thing, then they can set up a lot of these machines. And I was wondering how big that needs to be in order to become a majority. So I guess if it's a couple of millions, then it's a lot. And I
Yeah.
guess these are not simple machines, right? So they need to be very powerful machines, right? The
So
nodes.
they're not like the smallest or cheapest machines, but it's not like AWS machines of $5,000 a month. Usually it's like medium-sized machines with a lot of storage. Like holding a node takes a few terabytes of data, which is usually where most of the cost comes. And this is what makes it also very, very challenging to spin up a node, take about 48 to 72 hours until it becomes synced, until it takes all the information from other nodes and verifies
Ah,
it.
okay.
Yeah.
So
Because also, yeah, you have to remember that the idea behind the blockchain in general is because it is immutable. Everything that happened is historical and cannot ever change, because it was reached like a consensus was reached that this node this block was placed on the network and it will be there forever. In order for you to modify, you have to create a new one. And so basically the latest version will be the current. But historically, you can always look ahead. And every time you need to spin up a new server or a new node or whatever, you have to fetch all of the historical data from, you have to pre-populate it. And this is what Eli means, that it takes a lot of time and a lot of storage to do.
So the existing chain that there is, all the chain of the blocks that already have, that's
Yeah.
a couple of terabyte of data already.
Yep.
And how long that has accumulated? Like 10 years, right? I think Ethereum.
I would say probably yes, but I'm not sure.
So I was wondering, yeah. So I was wondering that okay, so it's just going to grow more and more, and then okay, a lot of disk space is going to be used. My understanding is that basically this is very similar to how the data of Git looks like, except of course without branching, and
Mm-hmm.
how the ability to go
We
back in
don't
history.
have
Yeah.
Sorry?
we don't have the way to go back like in Git. So versioning is
Yes. So in Git, you could remove all the recent commits and whatever. Here, I mean, uh, the same here, you could do this if you could convince all of enough nodes, right?
Yeah.
Basically.
Yeah.
Okay, interesting. So let's get back to Rust a little bit and you.
Let's do it.
So how did you get started with Rust?
Do you mean
First,
do you
let's
mean
start.
do you mean me or Ellie or both?
One after another.
All right, I think I'll start then. So, like I mentioned earlier, my journey to Rust was a bit different. So, over the past, I want to say almost 10 years, I've been dealing with, well, dealing is a choice word. I've been working primarily with Scala. And through Scala, which is a language on the JVM kind of, it's this hybrid object-oriented functional language. I discovered functional programming, and functional programming became something that I really fell in love with, and so I later learned Haskell and other kind of languages that are belong to that family. And through functional programming, I discovered many of the benefits that kind of were pioneered in functional languages and then picked up by every other programming language in the world. So, for example, things like virtual threads or green threads, as they're known in other languages, they were first introduced in Haskell, and then they were pioneered in Scala, and now Java has them, and of course Rust have them in basically Tokyo is the implementation of virtual threads. And the whole notion of immutability and working with immutable data and transformations like in C# they would be called link. In other languages they would be called working with collections and lambdas and iterators. There was kind of all of these features were kind of, I wouldn't say pioneered, but they were heavily used in functional languages primarily because you don't have as many variables and mutation going on. So you have chains and transformations of data. And so, unfortunately, I want to say, like, I'll be frank that unfortunately, Scala is notoriously hard to teach because of that. Because you can use it as a kind of a Java with this different syntax, but this does not really give you that much of a benefit, especially today when you have languages like Kotlin or other things that work on the JVM that don't necessarily require the full power of a language like Scala. And so many companies that were previously using Scala, they're kind of not really starting new projects on that. So they're kind of moving away. And so I was actually looking to do some more Scala, and it was becoming challenging. And so my options were either to go kind of into the mainstream and do maybe a little bit of Kotlin or even TypeScript and there are not a whole lot of choices for doing backend engineering, but most of it revolves today around Java and Kotlin and TypeScript on the backend. There's some Python probably. Or I really wanted to look at this language called Rust, because what I knew of Rust is that it was, yes, it was kind of a type-safe, very performant language that was created by Mozilla for a certain purpose. But what I knew of Rust is that it was designed in a way that it borrowed a lot of features from functional languages. In particular, if you look at the way that Rust is designed, it borrows a lot of ideas from, for example, from Haskell, which is known to be like a pure functional language. But in Rust, for example, the derivation mechanism, so the way that you attach essentially behavior to structs with the derived keyword, this is an exact copy of a feature from Haskell. It's called type classes. But this is a feature that exists in Haskell and was adapted to many other programming languages. And in my opinion, this is one of the most amazing features that Rust has, because it allows you to precisely define behavior to a set of structs or a set of traits, essentially. Traits become behaviors, and you can apply them externally to the data. So whereas you have in many object-oriented languages, you are encouraged to kind of create behavior and data together in the same class. In functional languages, in Rust specifically, you are encouraged to keep them separate. So you have structs that hold just the data, and you have traits and implementation of those traits as behaviors, which can be attached and reattached and defined, and most importantly, verified at compile time. So one such example is that something I've encountered yesterday. So I was refactoring a piece of code and I needed to store two new fields, or at least one new field of type float. I needed the floating point number to be stored in a configuration somewhere. I got a compilation error that said I cannot use derive EQ, derive equality, for a type F64. And this makes complete sense. You cannot, computers do not like comparing floating point numbers. This is an impossible problem. Now, there are many programming languages that are happily going to let you compare two floating point numbers. And the end result will probably not be what you need, what you expect. So you will have some issue at runtime. But Rust was smart enough to figure out that you cannot derive equality for the entire config class because the float type F64 does not implement the EQ trait. And this is why you got a compilation error, and it makes perfect sense. And the point is that in Rust, I found that many of these things are like this. So I'm just going to say that people who are coming to Rust, they hear stories about this compiler and the borrow checker being in your way constantly, and you have to kind of fight the borrow checker, so to speak, to get to the point. But I think that's the wrong way of looking at it. I think the compiler is there obviously to prevent invalid behavior, invalid programs, undefined behavior. So this is one of the core principles of Rust, is to be safe. The safety is achieved by it preventing you from doing things that will obviously not work. And many smart people created it, and I've seen many talks by the creators of Rust, by Graydon Hoare, who talks about the kind of the history and why they did things the way they did. But the main idea is that Rust borrows many of those features from languages that have strong and static type systems that kind of are in your way, but in order for you to prevent you from doing kind of the wrong thing. And finally, I'm going to say that one such mention about the borrow checkers, this is something I heard from a friend who does not do any Rust. He's a Scala programmer. But he asked me, don't you get to fight the borrow checker a lot? And I would say that this notion of fighting the borrow checker is kind of a meme. It's kind of a myth in the Rust world, because it is being sold as this kind of novelty feature that the Rust compiler has. It has this notion of a borrow checker. But the idea there is that because it has manual memory management, you don't want to be doing things that are wrong. So if you want to pass a mutable variable to another function, you have to explicitly allow it to be passed as mutable, because somebody can modify it under your feet. And the Rust compiler is smart enough to detect such cases and tell you, no, you're doing something very wrong. And so it's not there to kind of prevent you from doing stuff. It's there to guide you, or saying, okay, I know what you're trying to do, but there are ways of doing it, and you better stick to the ways. And finally, the last kind of, it's more of a philosophical thing that I'm going to say, is that there's this notion, again, coming from functional languages. It's a thing that's called it's based on a very good talk that I watched many years ago. It's this notion of constraints liberate and liberties constrain. So the idea is that if you don't have any constraints and you can do just whatever you want, like in other programming languages, JavaScript. So if you don't have any constraints whatsoever, so you can do just whatever you want, which means you can do it in any way that you want, in any style that you want, in any order that you want, probably. And then what you have is, down the line, you will have problems. You will have runtime issues, you will have refactoring challenges, and you will have many things that we know and love about languages like JavaScript. Now, if you have a system that's constrained, it does not let you do what you want, but it rather expects you to follow its exact kind of guidelines and its exact path that it guides you through, that there are very few ways in which you can implement something. So this notion of constraints liberate is that when you are constrained, kind of, it sounds paradoxical, but when you are constrained by the system that you are building it, by the type system, by the borrow checker or whatnot, you are then free to kind of implement it in the only way that will work. And so you don't have to worry about that. And that's for me that's just one of the most tremendous benefits of using a language like Rust. And also I'll have to give credit where credit is due. Also languages like Scala and languages like Haskell, of course. And there are some other languages that on the Microsoft side, there's F sharp. Many functional languages embrace this principle. And of course, type system really helps. So if you don't have types to guide you, you have to write a lot of tests. And we can debate whether or not writing tests is a fun activity now that AIs can do it for us. But I would say that types, from my perspective, come before tests. They can prevent many of invalid behaviors, even making writing these tests unnecessary for things that cannot possibly compile. Okay, and with that, I'm going to stop talking for now. And please, if you have any follow-ups, I would.
Yeah. So before letting Eli also say, I wanted to ask you, how did you solve that problem with the floating point, comparing floating point numbers?
Or well, the point is I needed to store a percentage, a multiplier for a percentage. I ended up storing it as just a decimal number. I just switched it to a U64. I used a different multiplier essentially. But yeah, it's just one of these things.
Okay, good.
Yeah, so I changed the data type essentially. I didn't try to hack around the problem. I solved it using a different data type.
So I guess my version is going to be a little bit more dull, but it's going to go through the same main theme of the language guiding us towards the right thing. So when we started working with Rust, it was the first time we coded in the language, and both my partner and I didn't code in that intensity for a very long time, especially me as a data science. I didn't do such things for a very long time. And when we started working on the software, it was something which did a lot of things in parallel. We got a lot of data from many sources in parallel. We had to do a lot of computations in parallel and store them back to the same sources in parallel. And one of the things we started feeling at the beginning is that we're fighting the borrow checker all the time, and that it's just interfering with our work. Eventually, like probably something which happens to most Rust developers, we started to figure out what's the right thing to do, when we need to clone an object, when we have to share it with an arc, and when we have to use a lock to share the object between different components. And one of the things which really impressed us after the first month was that it was a very large system in regards to the amount of parallelization it did, and it had no locks at all. In any software, in any other language I use, I was going to write and use a mutex in many places to synchronize. And here, because the language just encourages the developers to think about who owns each object, it just led us to write it in a way which didn't require any lock. And the performance was great, not just because it was Rust, also because it had no locks and we didn't have to wait in any place, which we wouldn't have happened in probably any other language we used.
Very interesting. Very interesting. Okay, so let's go further with Rust.
Yeah.
You said that part of the reason you selected Rust is because, or part of the advantages that you have from Rust is that you have a lot of libraries, crates that you can already use because they are part of the node, basically, right?
Yes.
So those are given that are part of the node, and you're going to use it, and whatever. I mean, even there might be the question is valid, but I'm quite sure that you have also all kind of other crates that you are using. I mean, every Rust project uses hundreds of crates.
Right.
How do you select a crate? How do you make sure its quality?
Yeah. Well, that's a very good question. I will say that at least until now, because the platform itself that we are basing upon, it was already kind of It's more or less batteries included. It has everything that we would need to kind of build upon it. It's an SDK essentially. So I don't remember if we needed to add an external crate other than possibly a, 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 a I think it was like some data types for that have to do with Ethereum protocols. Like we needed to bring in one more protocol that we needed to support, and I think there was a crate for that. But it's just a matter of Googling for Rust and whatever it is you're looking for, and looking at top two results. Now, I would say that most of the crates that are used, they are used mostly by reputation. So I wouldn't say necessarily number of stars, but it's more like a word of mouth thing that if you, for example, if you're building a CLI tool and you need a command line argument parser, so you would probably use clap. Why? Because everybody uses clap. And this is like in every book and every tutorial. Uh, and so if you need, obviously, if you need asynchrony, you would use Tokyo. And I know that there are other implementations, but they are maybe not as powerful, or maybe not as popular. Maybe they have their uses, but Tokyo seems to be kind of the I wouldn't say standard library, but it's kind of the de facto thing that everybody else uses. And of course, you need to think about interoperability. So to answer the question, I would say if we needed to, we would probably choose it by reputation. So how popular it is, whether or not it's registered in the official website. Like, is there, like, can I even pull it from, like, can I even add it to my TOML file and just rebuild and everything will compile, or do I need to add some third-party GitHub URLs to my configs to pull it from source, stuff like
Do
that.
you encounter crates like that? I mean, I haven't encountered.
No, but I suppose that there are private implementations somewhere that are not published. I personally haven't encountered that yet, but
In the
I'm sure.
Python world, I encountered is that you can't just pip installs the latest of something or
Yeah,
any, but you have to go to
yeah,
that. There I encountered, but maybe that's partially because I don't know, because
yeah,
Python is older and more.
yeah,
Um,
yeah. And
and
Rust, it becomes very easy because version pinning is very important. Like you have the log files, and I think from many like package managements software that I've used over the years, I think Rust did it really great because it kind of works, and it tells you what the latest versions are. It figures out mismatched versions between, like, if you have dependencies between crates, the Rust will tell you, and enabling features independently. So if you, for example, you needed to enable Tokyo for a certain crust, if it supports it, then they have certain crate. I think I think that they did a really good job. Like Rust, in my opinion, is one of the most well-engineered languages for like that provides you with developer productivity. There are very few, like the only one I can possibly think of that does at least as good job is a language called Elm, which is a web language that's also kind of functional, and it's also has its roots in Haskell-like syntax, but its package management and its errors are just amazing. Like it will tell you exactly what happened and how to solve it. And in fact, kind of jumping as an aside, Rust's errors are notoriously, yes, they can be overwhelming sometimes, but they're notoriously so detailed, is that you have AI tools today that just figure all the errors out and explain to you what went wrong, and just fix it for you. This is something I encounter daily. Even if I don't want it, sometimes I do encounter an issue with like borrowing or stuff like that, or forgetting to clone something. So sometimes I really don't, I want to get my task done, so I don't really want to think about it. So I just press the little icon in my IntelliJ that tells me fix with AI, and it just does. Why? Because it has a lot of context for what went wrong, and the LLMs are now smart enough to kind of feed this context, read this context, and just figure it out and give me all the information. So I don't have to Google, I don't have to read docs. It's really an amazing flow that is just incredible to me. I've been doing software for many years now, and I don't remember anything remotely advancing in this incredible rate like AI and AI assisted tools.
About AI.
Yeah.
Or let's
Yeah. Sorry,
maybe
I'm
Eli
jumping
wants
from
to say
topic to
something.
topic. Yeah.
No, I'm glad we're talking about AI. That's it.
Okay. So I wanted to ask about AI, if you're already talking about this.
Let's go.
How much do you use AI? Which AI tools do you have you experienced with? Which one do you feel the best for, especially for Rust development, of course?
Sure. Eddie, you want to go first?
No, that's yours.
Okay. So I will kind of make a jab at Ali that he's the AI person in the company because the amount of time he spends explaining things to ChatGPT, it's amazing. But I will mention this from my perspective as somebody who's like a developer that's being introduced to AI assisted tools. So I'll skip to the end. Today, I'm preferring to use mostly coding agents such as Claude Code and recently a new tool called AMP from, I always forget the name, SourceGraph, which is a company that also they make products for uh, understanding and analyzing and navigating code a lot. So, but now they came up with their own agentic AI, and this is something that's really that took an incredible kind of it exploded with incredible rate in the past couple of months, really, of from my perspective. But to go back to AI first, when Google's Copilot was introduced, yes, it was nice. It was kind of a predictive code completion thing. So many people enabled it as long as they didn't have to pay for it. So after it became a paid product, some people stayed with it, some people didn't. I had value from it because when I was working with Scala, it helped me to fill in the boilerplate. Scala does have some boilerplate that you have to do. And so I paid out of my own pocket initially for GitHub Copilot just to keep it working and to keep churning out this boilerplate. Eventually, we switched to a company subscription, and then the tools became smarter and smarter, and I started to realize that they do understand your code better every time. So they keep this context. I needed an explanation from the resident AI expert, Eli. He needed to explain to me what are tokens and how all of this stuff works. And it's really, truly incredible how LLMs essentially are built. But the idea there is that the more context you have, the more code of your own you can shove into the AI, the better results, the better predictions you're going to have. And predictions are what AIs do. They do not understand the code themselves. They understand what is the next likely token to emit. So most likely they will emit the correct thing. And so over the months, over the last, I don't know, maybe couple, like I want to say 5 or 6 months that I've been using AI with Rust, I see much less, almost none of hallucinations that typically come with using LLMs. So, for example, LLMs like even like Copilot or even tools from ChatGPT, they don't necessarily when they don't know something, they will just make something up. They will make API that does not exist, and they will just suggest you to do things that are just impossible, for example. And since trying different models, and lately I've been using Claude's model a lot, Sonnet 3.7, and then now they last week they released 4.0. And so ever since switching to that, I've been seeing much less hallucinations, and it really does solve the issues, and also in a way that's straight to the point. No, not too many explanations, but then they just give me actionable solutions to, for example, compilation errors, or sometimes they just want to, for example, uh, let's see, I just want, for example, even I want to create a struct that derives whatever, debug and clone. I just sometimes instead of typing out the struct, the code, I will just type create a struct for whatever, deriving all these things, and it will just think for 2 seconds and just do it for me. So yes, I find AI used to be an incredible assistant. And I do think that we are at least in the beginning of I don't even want to say paradigm shift because I think it's a too big of a term for this, but I really don't remember anything kind of anything like this in the recent years that also explodes in the way that what's the word I'm looking for? Kind of improves every single time. Every week there's some sort of marginal, some sort of major improvement that just I don't know if I would be able to go working without AI assisted tools anymore because it's just when you figure out the flow, it's just a huge time saver. For example, I do instead of Googling, I don't remember the last time I Googled anything. I use Perplexity, which is another AI kind of AI aggregator that does searches for you and scans many websites and gives you actionable to-do lists. So every time I need to search for something, I don't go Google it. I just go to Perplexity or sometimes ChatGPT when I need the dialogue, and I find myself using it more and more. Now, of course, all of these tools cost money, and I'm sometimes happy for my personal use. I'm happy to pay for these things because I do get the value from them. It wasn't like that with many kind of developer assisted tools. Funnily enough, Ellie and I we used to work for a tooling company, and selling tools to other developers is very hard. Tooling companies are notoriously difficult to sell. Like the biggest kind of success I can think of is probably JetBrains, which is able to sell IDEs, but there are now talks about IDEs being a thing of the past. Now, whether or not it's a hyperbole, I don't know, but I do find many compelling reasons to shift the loop to outside of the IDE. The IDE is there to just read through the code, maybe use some syntax highlighting and do maybe analyzing of the work that was done. But the main part of the work is being done by AI, which is which is exciting and scary at the same time. I'm sorry, I kind of went into answering other imaginary set of questions, but that's where I stand. I really like AI, and I do feel that it brings a lot of value to my day to day.
Danny, would you like to add something to this?
So one thing which is was one of the pains a year ago. So when we started working with Rust and ChatGPT, we felt that both of us, my partner and I, don't know Rust. We coded a lot in Rust, but we don't know Rust, which was the first language I encountered this. It's also the first language I learned after the explosion of LLMs. So this was like something which was very troubling. Less than a year after that, so today was the first time I had a ticket which was done solely by an agent. So my whole work in the ticket was just to copy paste the Jira ticket into AMP code, and that's it. The implementation was the right in the first place. It went online. Even we have an AI in GitHub which also reviews the PR. It gave a small comment, fixed it by itself, and that's it. I didn't do anything in the ticket other than copy pasting the Jira ticket into the prompt. This was something which was exciting. So I still don't know how do I feel about the worry from last year that I won't know Rust because I don't know Rust well. Probably there are many good developers who do it way better than me, but maybe I don't need to know Rust that well in the future because an agent will complement everything which I don't know how to do. So I wonder what will be the conclusion in a year or two from now, but it's a very different experience than anything in the previous 2 decades in coding.
Very interesting. So I'm not sure if the next question is even relevant anymore. I wanted to ask you, I'm guessing, or I was guessing earlier, that you're looking for more developers being a startup. And I wanted to ask you, okay, what would a person who wants to apply to or get picked up by you, what should they invest in if they had like 1 month now to prepare or 2 months to to be a better candidate for you. But I'm wondering now, do you even really need more people, or you're just sit down, write the tickets, and then you click 2 buttons and it's done?
The official term for this is vibe coding.
Yeah.
Semi-official. Yeah.
So there's a very good question regarding this. So there's one thing that many tickets are still very hard to develop. They're conceptually hard. The algorithm behind them to implement are not that trivial, and they're new by nature. And I believe that an agent or any LLM won't be able to implement them end to end at the beginning. So someone with deep understanding of coding, engineering, infrastructure will still be very relevant. And there's something which Igal uses a lot when we're talking about Rust developers. They're self-selecting. So not many people go to learn and develop in Rust by themselves. Probably I'm an exception because I didn't have to choose it. Rust chose me. But many people just go there and decide they want to do Rust. And usually these are people with a great passion for coding, internals, understanding. It's not a language where people come because it's very elegant or the code looks very nice in the syntax. So I guess one of the things is that people who want to join the team are people who really, really love Rust and have passion to it and want to learn more of it and do a lot. Another aspect which is probably unique to us is that the context of Ethereum development is also quite challenging, because practically what we're doing is we're developing or working on something which executes a code of another virtual machine of another language. So one of the things which are very important are people who also like coding in general, and some experience in Ethereum is very helpful, like to understand the protocols, how it works, how the virtual machine works. It gives a lot of advantage and reduces a lot of the pain in the work.
Okay, so I guess the answer would be now that, okay, so if there is a Rust developer and she or he wants to join your team because they really like the idea, then they should invest in learning Ethereum and try to learn that, for example, right?
Yeah, that's one of the things which helps most.
Okay, that's sort of like the internal things. Would like contributing to open source project be something that you look at the people that so if I go and contribute to open source projects, would that be something like a good point for me, or you don't care about that too much?
So we give it a little bit of good points, especially to anyone who works in open source. It reflects something of the excitement and passion of the developer. But the main thing we saw that like real experience, like being post the fight of the borrow checker, is usually where people have more advantage with their experience. So some experience in real work with Rust is the thing we're mostly looking for.
Okay, and then finally, I would like to change a little bit the direction of the audience. And by the way, we didn't have any question from the audience, so the people who are present. So if you would like to ask anything, just please type in the chat. But I wanted to ask, I mean, from my point of view, the last question, we are still waiting for the guest, is to the audience of other managers or entrepreneurs who try to set up their own startup company. What would you tell them when selecting Rust or not Rust? I mean, for you, it was a little bit less of a choice, though you did try Python. But what points should they consider better to use Rust or not?
So from my point of view, the main challenge is the lack of talent. So there are very few people locally, but also globally, with enough experience in Rust. And because a lot of those people joined many startups, especially in our area, in blockchain companies, so the fight and competition over talent is very difficult. So it means that it's going to be a price that the startup is going to pay. So if a startup can choose to take a different language, like a simpler one, even C Sharp, then the chance to finding developers more easily is significantly higher. Going with Rust means that at least for the next year or two, getting talent is going to be challenging. So that's the main thing. I'd say we like the language. We found that the ecosystem is rich enough to support almost everything we need. So it's like very like that it fills everything we need. Just we don't have enough people to fill everything we need. To be honest, we just managed to hire all the people we needed for the team, but we had to sweat a lot for it. It was more challenging than we expected. And also, I'm not sure that in regards to choosing it as a language to just a general backend service system, I'm not sure that that's the right language to use. Like more infrastructure, like processes, things which needs to work with high load, probably justify it a little bit better.
Yeah, I actually do want to add because I think we kind of discussed this question ahead of time. And also, me personally, I was responsible in the previous company. I was responsible for training and mentoring Scala developers. Now, Scala and Rust are pretty much in the same boat with regards to scarcity of talent. It's a difficult language to pick up, and there are many way kind of more forgiving languages out there. So why specifically Rust, or why specifically Scala? So I guess if you have needs, now again, Rust was developed. So I'm going to say like two things. First of all, if you don't have Rust talent but you really need to, you can hire, and you should hire quality engineers with a good resume and good kind of, yes, open source contributions are always kind of welcomed, but we're generally looking for people who creative thinkers and problem solvers, and people who can just they know how to learn things, and I am pretty sure they can pick up any language fast. So the goal is make your own, kind of invest. So this is what we're trying to do. We're trying to also invest in training resources, in material for making our own Rust developers eventually. Whether or not we need to buy books or courses or do internal kind of sessions and stuff like that. So this is all part of the growing of the company that all companies in early stage should invest in. But I will say, however, the negative, if there's one kind of why not pick Rust, is exactly like Eli mentioned. I think that if your primary product is just a backend web server, you need to handle like web requests or serve websites. I might think that Rust might be a slight overkill for that. Yes, you can use an HTTP framework and serve it, but there's going to be way too much friction for getting things done quickly. I mean, you would much rather have a JVM based language like Kotlin or Scala, obviously, or even TypeScript. There are many great big companies that do backends on TypeScript today, and it just works, and it's very fast. I would say if you're a company that develops servers, products like that have to run and serve a lot of connections and a lot of be under high loads all the time. Things like Redis, for example, which is also written in Rust or being rewritten in Rust. There are many other companies that I know that develop these tools. Or if you primarily need to work on commodity or commodity hardware, for example, if you need to deploy products like browsers, for example, to end customers who might not have very fast machines. You might consider a language like Rust or a native language that will compile to a small executable and be very fast. But of course, you could pick a language like C# for that. Again, there are trade-offs in many of them. From my perspective, and kind of to conclude this, I would say it's in the end, you have to decide as a manager, as an engineering manager, what's kind of you have to pick one out of the two options, whether you prefer correctness or do you prefer well anything else. Like how important it is to have a bug-free experience for you. Like if you place it higher up, then you should probably pick a language like Rust that will prevent you from having runtime surprises, if I say so, if you use it correctly. Of course, there's many gotchas in Rust. Like if you use it incorrectly, like if you unwrap everywhere, which is the wrong way of using Rust, but many people do because it lets them compile the code. So no, unwrapping is the exact wrong thing to do. And until people realize that, they will be using Rust wrong, and they won't get any benefit from it. They will see that it's actually it's not protecting them from anything. They will have runtime panics. So they need to learn to understand that unwrapping is not what you do, for instance. And it's a learning curve, like with many languages. I think Rust has an additional learning curve because it introduces a couple of novel ideas that do not exist in many languages. Like people coming from Java or even C++, they don't necessarily know of all of these mechanisms for separating data with behavior, for example, derivation or things like even the macro system would work differently, I suppose. Like I said, there's learning curve. You have to invest in it, and it's a matter of a trade-off. But the bottom line is that if you make servers, you probably want to look into Rust. If you make general backend servers like serving websites, you would likely do better with using a less difficult language to master.
Okay, thank you very much. I ran out of questions, and our audience is rather silent today. Do you have anything else that you wanted to talk about that you think that I should have asked earlier and I didn't?
Well, first of all, I just wanted to thank you again for inviting us. This is really fun, and I like to geek out about this stuff. Sometimes it's very difficult for me to stop talking, and so hopefully the reason there are no questions is that I inadvertently answered them all, hopefully, or not. We'll find out maybe from feedback on this episodes when it comes out. Um, but I think we covered a lot. I think the questions were great, and I'm looking forward for this podcast to run for many, many, many years and have many, many great guests. And maybe before we leave, I will provide our socials and how to reach us. If there are any follow-up questions, I would be more than happy to answer, even in a
Definitely.
mail or Twitter, X, or even just a private Zoom. That's also always welcomed. I'm happy to talk about these things.
Okay, so you want to say them, or we'll just add them to
Yeah,
the...
you should probably add them because my nicknames are weird. I have to spell them out.
Okay. Ellie, you wanted to add something?
So I don't have anything to add, just have to say that I'm really excited that a new community of Rust is being built and people are attracted to it. It's a very exciting language, very exciting technology being built with it in many projects, and we're very happy that this forum exists.
Well, I really thank you very much for being here and all kind of really fun information and insight we got. And thank you for the audience who was listening silently here. And thank you for everyone who is listening to the podcast. There are going to be show notes with all kind of links, so please follow them. And thank you very much. Goodbye. Bye bye.
Thank you.
Thank
Bye.
you.